Okay, in this video, we are going to be doing AP Review Quiz number 3. So let's take a look at the problems. A particle moves along a horizontal axis with velocity v of t, which is cosine of 2t plus 1/2, between 0 and pi. If x of 0 is 2, find x of pi. What I'm going to do is I'm going to rearrange the fundamental theorem. This is my favorite way to use the fundamental theorem. I just write that x of pi over 6 is going to be x of 0 plus the integral from 0 to pi over 6 of v of t, which is cosine of 2t plus 1/2. Now I have to actually integrate. I know that x of 0 is 2 because that is given. Then we have to integrate cosine of 2t, which is going to be 1/2 sine of 2t, and then the integral of 1/2 is just going to be 1/2 t. And we are going from 0 to pi over 6. So we have this. Now we have to sub in. So we have 2 plus. When you plug in pi over 6, you get the sine of pi over 3, which is root 3 over 2. So we'll have 1/2 root 3 over 2 plus 1/2 of pi over 6 is pi over 12. Minus, when we plug in 0, everything is 0. The sine of 0 is 0, t is 0, so that just zeroes out. And then we would want to clean this up. So we end up with this, which is obviously 2 plus root 3 over 4 plus pi over 12. All right. Okay. Part B, find the distance traveled by the particle on the time interval during which the particle is moving to the left. So we have to figure out when the particle is moving to the left, which means velocity is negative. What I'm going to do is actually just graph the velocity function because I have a pretty good handle on graphing cosine graphs. I recommend that you review that every once in a while. I know that we're going to go 1/2, and then you can go up and down 1. And also, I know it's positive cosine, so it starts at a max. So it's going to do this, and then fill in that. And we are looking for where this is negative. I now just need to find the x-intercepts, right? So I need cosine of 2t to be negative 1/2, which means that 2t is either 2 pi over 3 or 4 pi over 3. Memorize the unit circle, and you will know those values, which means that t itself is pi over 3 or 2 pi over 3. Now the issue is we're looking for distance traveled, not displacement. If I try to find the integral from pi over 3 to 2 pi over 3, it's this region, I will get a negative. So what I'm going to do is I will take the negative of the integral. So I'm doing the negative of the integral of velocity. The reason, again, is because the displacement would be negative, and I want the distance traveled. So now we're just doing this. So same integral, basically, negative, and then our antiderivative from pi over 3 to 2 pi over 3. We've got to plug everything in. We're going to get, when we plug in 2 pi over 3, we will have 1/2 the sine of 4 pi over 3. So that's going to be 1/2 negative root 3 over 2, and then plus 2 times 2 pi over 3, which is pi over 3. So all of this, minus, when we plug in pi over 3, we get 1/2 the sine of 2 pi over 3, which is positive root 3 over 2, and then 1/2 of pi over 3 is pi over 6. So we'll get all of this. Again, memorize the unit circle so that you know these values. We need to simplify this. It's going to simplify down to just give us root 3 over 2 minus pi over 6. Okay, let's look at the next part. On what time intervals is the particle's speed increasing and we want to justify? So speed, we need the velocity, and we need the acceleration so that we can figure out where they're both positive or both negative because we want increasing. So we already know velocity. I'm just going to copy that over. Acceleration, I'm going to take the derivative of velocity. I should have written that a of t is v prime of t. I really should have written that. And now I'm going to graph this, which is just a negative sine graph. Same period, looks like this. I will use these now to make my sine charts. So I'm going to make a sine chart for v of t, which you can see we're just visually looking at our graph and filling in pluses and minuses. We can make a sine chart for a of t. Again, we're visually looking at the graph where the graph is below 0, where it's above 0. We fill these in. Now we can answer the question. So I'm going to say that speed is increasing from pi over 3 to pi over 2 and 2 pi over 3 to pi because velocity and acceleration have the same sign on those intervals. So speed increasing pi over 3 to pi over 2 and 2 pi over 3 to pi. And my reason is because v of t and a of t have the same sign there. Let's take a look at the next question. So evaluate the limit as x approaches 5 from the left of x minus 5 over the absolute value of x minus 5. We're just going to graph that and use the graph. This is a famous graph. We should have it memorized. At 5, there's a key point. We know it's -1 and positive 1 are the only outputs. To the left, you get negative 1. To the right, you get positive 1. Fill it in. There you go. Now we want to approach 5 from the left, so we're just going to get negative 1. That question shouldn't really take any longer than that because this is a review quiz. All right, let's take a look at question 3. Find the derivative with respect to x of arcsine of x to the 5th. All right, you should have the derivative of arcsine memorized. It's 1 over square root of 1 minus u squared times du dx. So we're going to chain rule this thing. The derivative of arcsine is 1 over the square root of 1 minus u squared, u is x to the 5th, times du dx. The derivative of x to the 5th is 5x to the 4th. Our answer is 5x to the 4th over the square root of 1 minus x to the 10th. Again, this is a review problem, so we're moving kind of quickly because hopefully you've seen this before. If you haven't, lots of videos tell you what to do. All right, let's take a look at number 4. And it's given that g of x is f inverse, and we have these values, find the equation of line tangent to g at x equals 3. All right, we'll do our usual setup. We know that for g of x, we know that x is 3, and we want to know what y is, which means for f of x, we know that y is 3, and we want to know what x is. So we know basically this. We're going to go to the table for f of x, find the 3 in the y column, f of x column, and that'll tell us what the x coordinate is for f, and therefore the y coordinate for g. So I always set it up like that. I always find the ordered pair on g of x from the ordered pair on f of x. Now I know that g prime of 3 is going to be 1 over f prime of 7 because I studied and I remember that. I know that f prime of 7 is negative 4, so we're looking at negative 1/4. And then our tangent line, make sure you use the ordered pair for g of x. We are going to get y minus 7 equals negative 1/4 x minus 3. Good problem. Let's take a look at the next problem. Identify each discontinuity and its type for the function shown above. We're going to have to factor because that's how you find the discontinuities of this thing. So I'm going to start with f of x equals, in the numerator, I'm going to go 3x and an x, and then I think we're doing plus 4 there and a minus 1 there. And then all over, we're going to go with 3x again and x again. But in this case, we're going minus 5, minus 1. So from here, we can simplify to get just x plus 4 over x minus 5, provided that x is not 1/3. The reason x can't be 1/3 is there's a removable discontinuity, right? So we have actually removed the discontinuity by canceling those factors. So we know removable discontinuity for sure at x equals 1/3. Now there is still an x minus 5, which means we still have a vertical asymptote to account for. Vertical asymptote at x equals 5. Those are the only discontinuities. I just want to throw in a warning here because a lot of people, when I actually gave this quiz, gave this answer. Horizontal asymptotes are not discontinuities. There is no reason you would be listing them here as discontinuities, so don't do it. All right, let's take a look at number 6, which I think is the final problem. The differentiable function f of x passes through the points negative 2, 5, and 1, 3. We want to prove that f of r equals 4 for some r between negative 2 and 1. So that's on the same level. We're given f and we want to prove something about f. That's almost certainly going to be the intermediate value theorem. So to use that, I need the function to be continuous. But we only know it's differentiable, so I'm going to start off with f of x is differentiable, which implies continuous. Now I'm allowed to use the intermediate value theorem. I'm going to actually list the function values. So I'm going to say f of 1 is 3, f of negative 2 is 5. From there, I'm going to say f of 1 is less than 4 is less than f of negative 2. Therefore, f of r is definitely equal to 4 for some r value between negative 2 and 1, and my reason is the intermediate value theorem. That's all you're doing on this. The keys are you have to go from differentiability to continuity, you have to show that you are below the value and then above the value, and then you should cite the theorem. As long as you're doing that, you're going to get all the points. All right, and then part B, we want to prove that f prime of c is negative 2/3 for some c between negative 2 and 1. If you're proving something about f prime, given stuff about f, you're almost certainly using the mean value theorem. To do that, we need differentiable and continuous, so we're going to start this in the same way. F of x is differentiable, which implies continuous. So I'm using the mean value theorem, so I'm going to say, therefore, by the mean value theorem. And now I'm just going to write the conclusion or the work step, I guess, of the mean value theorem. It's going to be that f prime of c is equal to f of 1 minus f of negative 2 over 1 minus negative 2. And then that is definitely equal to negative 2/3. It was actually the only option in this problem because I only gave you 2 points. I really wanted to hone in on, are you writing your justifications correctly? And when I do that, I often find out that some of you are not doing that. So make sure you are really reviewing what these look like and just make your work look like it. You will get all the points. And then we're going to say for some c between negative 2 and 1. All right, so that's the entire quiz. I hope this was helpful, and good luck.